Okay, so recording has started. So what we're going to do in today's session is we're going to look at mainly skeleton and bones in today's session. But first of all, we're going to do a little recap on the cardiorespiratory system that we did yesterday. So I've got a little quiz for you. So if you can please close any notes, any slides that you've got from yesterday's session, if you can close those, and all you need is a pen and a piece of paper, or if you wanted to use your laptop just to jot down your answers. We're going to do multiple choice quiz. There are 10 questions for the quiz. Here, can everybody see that? You should see the learning outcomes from yesterday on the screen. Can everybody see that?
I can only see you on the screen, mate.
You see me? Bear with me. If I turned off sharing. How's that?
Oh yeah, respiratory system.
Got it? Cool. No, that was my fault. I think I clicked the wrong button. Okay, so you should have respiratory system and then our quiz on the next slide now. Yeah. Got that? Cool. Okay, so as I said, make sure you've got a pen and paper or just somewhere where you can note your answers down. There are 10 questions. All of the questions are multiple choice. There's only one correct answer for each of these. I'm not worried about what score you get, but the pass mark for the whole exam is 70%. So on cardiorespiratory system, you'll be able to identify, okay, I'm pretty clued up on cardiorespiratory system, or I need a bit of extra work to do to upskill my knowledge on this. So we'll go through the quiz now anyway, and we can have a chat through them when we do the answers. So I'm going to go through all of the questions and then we'll do the answers at the end. Is everybody ready to go for this?
Yeah.
Cool. Okay. So question 1. The structures that prevent backflow of blood between the chambers of the heart are A. Atrioventricular valves, B. Ventriculoatrial valves, C. Ventriculoarterial valves, or D. Atrioarterial valves. A, B, C, or D. I'll bring up question 2 as well and then give you a bit of time to jot your answers down. So question 2 is describe the flow of blood through the heart. Is it A. Vena cava, right atrium, left atrium, aorta? B. Pulmonary vein, left atrium, right ventricle, pulmonary artery. C. Right atrium, left ventricle, pulmonary artery, lungs. Or D. Pulmonary vein, left atrium, left ventricle, aorta. Okay, I'll give you a minute or two to view those. If you want me to repeat the questions, just let me know. So all you need to jot down is A, B, C, or D for your answers. Make sure you keep track of any questions, and I can recap some questions at the end if you want to before we go through the answers. Okay, happy to move on? Sinead, Aaron, give me a thumbs up if you can.
Oh yeah, just give us a second.
Yep. Okay, I can always put it up at the end again to recap if you want to come back to it. Okay, so question 3. Which side of the heart receives blood from the body? Both, left, right, or atrium? Which side of the heart receives blood from the body? And I'll put question 4 up as well. Describe the flow of air to the lungs. Is it A, nose, pharynx, larynx, bronchus? B, nose, larynx, pharynx, trachea? C, nose, pharynx, larynx, trachea? Or D, bronchus, bronchioles, trachea, alveoli? Again, I'll leave it up for a minute. Okay, got some answers? Cool. Okay, question 5. Gaseous exchange in the lungs is also known as what? A, systemic diffusion, B, muscular diffusion, C, pulmonary diffusion, or D, central diffusion. And question 6. What blood pressure category has a systolic range of 160 to 179? Is it A, high normal, B, stage 1 hypertension, C, stage 2 hypertension, or D, stage 3 hypertension? Okay to move on? Yep. Sinead, Aaron, hope you're okay because I can't see you guys. Okay, question 7 and 8. So question 7, what is another name for the heart muscle? Is it A, smooth muscle, B, myocardium, C, coronary muscle, or D, voluntary muscle? And question 8, the flow of blood from the right side of the heart to the lungs and back to the left side of the heart is known as what? A, systemic circulation, B, cardiac circulation, C, coronary circulation, or D, pulmonary circulation? Ready for the final two? Okay,
yeah.
Cool. Question 9. What happens to the diaphragm during inhalation? A, lift the ribs up and out. B, draw the ribs down and in. C, contract and flatten. Or D, relax. And question 10, where does gaseous exchange take place in the lungs? Is it A, capillaries within the muscles, B, capillaries surrounding the alveoli, C, arterioles, or D, bronchioles? Would you like me to recap any questions or bring them up again? Nope. Go straight through to the answers? Okay, bear with me. Let me just get this set up again. Okay. So, question 1. Question 1. The structures that prevent backflow of blood between the chambers of the heart are? Anybody want to have a go?
Wrong with A, not too sure.
A, yes, correct. Atrioventricular valves. So the structures that prevent backflow between the chambers of the heart. So our chambers of the heart are the atria at the top and the ventricles at the bottom. So the valve between the two is simply the atrioventricular valve. Question 2, describe the flow of blood through the heart. Okay, so a bit of a tricky one, this one, to try and kind of get your head around each option, but anybody want to have a go?
D.
D, correct. Pulmonary vein, left atrium, left ventricle, and aorta. So into the heart via the pulmonary vein, through the left atrium, left ventricle, and out through the aorta. Question 3, which side of the heart receives blood from the body? Anybody want to have a go? Sinead, Aaron? A stab at that one. Okay, so the answer is C, the right side of the heart receives blood from the body. Question 4, describe the flow of air to the lungs. Anybody want to have a stab at that one?
I'll go with C.
C, nose, pharynx, larynx, and trachea. Cool. Yeah, very good. So nose, past the pharynx, past the larynx, and down the trachea, the windpipe. Cool. Just to give you a heads up, Kath has joined us. Kath is a new colleague of ours who's been with us a few weeks, so she's just jumping in to observe the session today as well. Okay. Moving on to question 5. Gaseous exchange in the lungs is also known as what? Anybody want to have a go? The lungs.
C again.
Pulmonary.
C again, pulmonary diffusion. So anytime you see the word pulmonary, it always refers to the respiratory system or the lungs. Question 6, what blood pressure category has a systolic range of 160 to 179? Anybody want to have a go? Say again, Sinead?
Is it the C?
C, yes. Stage 2 hypertension has a systolic range of 160 to 179. Good work. Question 7, what is another name for the heart muscle?
B, myocardium.
B, myocardium, correct. B. Question 8, the flow of blood from the right side of the heart to the lungs and back to the left side of the heart is known as what?
Pulmonary.
Pulmonary again, yes. D, pulmonary circulation. So remember, when we say lungs, pulmonary is referred to at the lungs and respiratory system. Last 2, what happens to the diaphragm during inhalation?
When we draw ribs down and in.
No, not the diaphragm. So that would be the intercostal muscles. So the
right.
diaphragm itself will contract and flatten. So if you remember, the diaphragm is that dome-shaped muscle that sits at the bottom of the ribs. When it contracts and flattens, it increases the space within the thoracic cavity. And finally, question 10, where does gaseous exchange take place in the lungs?
Capillaries surrounding the alveoli.
Good, yeah. B, capillaries surrounding the alveoli. Good stuff. Okay, so what I want you to do, just calculate your what you got right. So the pass grade is 7 out of 10. You don't have to share if you don't want to, but it's just for you to be able to identify how well you did. So just calculate your score out of 10. And I shall set up our next section. Cool. Okay, any questions or anything on anything that we've gone through there? Do you want me to recap any of those questions or clarify anything?
I was looking at the passage of air, and on the actual slide, it said there's a bicuspid mitral valve.
Yes.
That wasn't actually shown on the diagram of the heart, as with the tricuspid and the pulmonic valve. They're on that on the passage of air, but they're not on the actual diagram of the heart.
So what I've put on this, so this slide here, if I bear with me, where's my little? I'm trying to get my little laser pen. There we go. Okay, can you see my laser pen there?
Yeah.
Yep. Okay, so what we've got is bicuspid mitral valve is the medical term for the atrioventricular valve. So we've got specific valves on the left side of the heart, but also on the right side of the heart as well. So we've got our bicuspid mitral valve, which is simply the atrioventricular valve on the left side. And then on the right side, we've got the tricuspid, which is the atrioventricular valve. Now for level 2, you won't see bicuspid mitral or tricuspid valve, or you won't see pulmonic valve or aortic valve, wherever it's gone. There. Okay, you will basically see atrioventricular valve between the left atrium and left ventricle, and atrioventricular valve between the right atrium and right ventricle. Does that make sense?
Yeah.
Sure. So you don't need to know these kind of complicated names here. But I put them on there just so you're aware that they have those names as well. Okay. Okay. So if everybody's okay with that, we will jump into skeletal system. Let me just skeletal system. So what we're going to cover in this section, actually, before I do that quickly, just to quickly recap our ground rules. So just respecting each other's opinions and no stupid questions within the session. If in doubt about anything that I'm going through, please give me a shout. If I'm going too quick as well, please let me know and I can go back over it. Try to ignore any notifications on your phones and things like that. If you are using your phone for this, obviously no problem. Give the session your full attention. Be considerate to others. It's difficult on here where we're kind of going to talk over each other and things like that, but I'm not too worried about it because we've got a small number on, but don't be afraid to kind of jump in and ask questions. Just a recap of what we want to keep an eye on as we go through this session as well. Okay, so what we're going to look at in this session this morning is we're going to identify and locate the major bones of the human skeleton. Now that's going to be difficult with what we're doing on Teams here, but we'll have a go, and I'm going to give you a little activity to do yourselves for that bit. We'll then look at the functions of the skeleton. We'll identify the role of the spine and the effects of exercise on spine alignment. We'll describe the 4 types of bone and understand their development, and then we'll look at the effects of exercise, age, inactivity, and hormonal status on bone structure. So first of all, question for you. How many bones in total have we got in the skeleton?
206.
206, yes. So we've got 206 bones in total in the skeleton. Bones are attached to other bones via what? Can anybody tell me? What attaches bone to bone?
Ligaments.
Ligaments, yes. So ligaments will attach bones to other bones, and muscles are attached to bones by tendons. So if we think about ligaments as a link, so it links bones to bones, ligaments, and tendons will attach muscles to bones. So if we think tendons with regards to tension, so tension in the muscle will attach muscles to bone. Cartilage will cover the ends of the bone at a joint and allows friction-free movement to occur. Okay. So just a little introduction to the skeletal system. What I want to do now is ask you to, there it is, sorry, jump this up here. So this here is the list of bones that you need to know for level 2 fitness instructing. Hopefully you can see those okay. Did everybody see that all right? Give me a heads up if you can or can't. Can't actually see you guys.
Yeah.
Yeah, got it. Cool. Oh, got me again. Okay, so what I want you to do, and this is going to be difficult because we're doing it via Teams, is I want you to kind of go through each list of bones and then think about where each one is located within the body. What I'm going to do then is I'm going to give you about 5 minutes just to kind of go through, 10 minutes even, to go through each one. George and Adrian, if you want to work together on this one, that's absolutely fine. And then we're going to just write down a little description, or you're going to show me on the screen where each one is located. And I've got a skeleton beside me here, and I'll hopefully try to show you the ones that you are not too sure of. So just spend 6-7 minutes or so, go through the list, jot down where you think each one is located, and then as a group together, then we will kind of go through the location of each of those bones. I keep doing that. Sorry, I keep losing the list for some reason. It keeps jumping. Okay. Is everybody okay with that? Everybody understand what they've got to do?
Yeah, all good.
Okay, so a couple of minutes, just going through each one, think about where it's located, and then I'll run through it using the skeleton. if you have finished this, you can simply click on the raise hand icon at the top of your screen, and that'll show me that you've finished. But no, oh, guys, we're done. Fair play. But don't rush it. You're done as well. Erin, you okay? Just for another minute or two?
Yeah.
Okay. Good to go. Should we go through them? Okay. So what we'll do is we'll go through each of the names. Can you all see me on the screen for a start?
Yeah, I can see you.
Yeah, make sure I'm visible. It might be worth if you could change your screen to make it bigger, because I've got a friend with me that I'm going to use, so making sure that you can see what I'm pointing to on this as well. So if you need to make the screen bigger, and don't be afraid to kind of get the list off the screen if that's going to help you to make this the screen bigger. Okay, so we're going to go through each one. I'm going to do my very best to kind of show you where it is, but I want you to kind of, give me feedback, show me where it is. So if you can turn your cameras on, you can simply show me on your body where it is, or you can describe it to me where you feel, where you think it is. So first of all, if we look at down the left-hand column, so we're going to start off with the carpals. Can anybody tell me where the carpals are located? In the wrist. Okay, yeah. So I've taken his arm off to make this a little bit easier. So in the hand of the wrist here, we've got the carpals, which are situated just in this position here. So at the bottom of the arm, within the hand, we've got the carpals. In the wrist, okay, are the carpals. Okay, so they are small, kind of cube-shaped bones that sit between the arm and the hand itself. Perfect. Cervical vertebrae. Can anybody tell me where they're located?
Top part of your spine.
Yes, so the top part of the spine. So situated, right, come here to me, you. Okay, so situated right here as part of the neck, so the top section of the spine. Clavicle. Can anybody tell me where the clavicle is located?
Like
On
the
the back.
shoulder.
Sinead, yeah.
and the
Shoulder? Yeah. Anybody tell me what it's also known as, the clavicle? So you are correct. It's this bone here.
Collarbone.
Collarbone.
Collarbone, yeah. So the collarbone or the clavicle situated in the as part of the shoulder girdle. Good. Coccyx. Can anybody tell me where the coccyx is?
Base of the
Erin, do you
spine.
want to have a go? Yeah,
Oh,
base
sorry.
of the spine. That's all right. That's all right. No worries. Base of the spine. So let me lift him up here. So right at this bottom bit here, we've got the coccyx, which is the bottom section of the spine. I don't know how well you can see that. Right at the bottom here. Cool. Coccyx. Cranium. Yep. So the skull. So cranium. Ooh, right at the top here, we classify as the cranium and the skull. Femur. Anybody want to have a go at femur?
Is that where your like quads are on your leg, the top of your leg?
Good shout. Yes, very good. So come up here. So the femur, the largest bone in the body. So the thigh bone, as you said, so where the quadriceps are located, the hamstrings are located on the back, is that large bone at the top of the leg, the thigh bone. Perfect. Good. Where was I? Ulna. Anybody know where ulna is located?
Forearm. Smaller bone.
Yes. So the forearm, bear with me. Go back in here. So the forearm. So if we look at my forearm, the ulna is underneath. So as I kind of put my thumb up, The ulna is the bone underneath here. So if I show you on this, so the thumb up, it's the bone underneath. So U for under, ulna. This one here. Okay with that? Scapula. Do we know where the scapula is?
Is it like the behind the shoulder, like the back part?
Yes. So also known as the shoulder blade. This bone here, nice big flat bone that sits at the back. Yeah. So again, part of the shoulder girdle, the scapula, shoulder blade. Thoracic vertebrae. Anybody know where the thoracic vertebrae are?
Second part of your thoracic spinal.
Yeah, so again, part of the spine and the second section. So if we've got the cervical section at the top here, we've then got the thoracic section here, which links up with our rib cage. So the thoracic section of the spine. Okay, metacarpals. Anybody tell me where they are? Metacarpals? Yes, in the hand. Good. So in the hand, so if I show you on here, we've got the next section down. So our metacarpals. So we've got our carpals and then metacarpals down here. Metatarsals. Can anybody tell me where? If you've got metacarpals in the hand, where do you think we'd have metatarsals?
Same, but in your feet.
In the foot. Okay. So, sorry. So in the foot here, so metatarsals, the bone in the foot. So you may have heard of footballers who have broken their metatarsals. So right in the foot here. Good. The patella. Is the kneecap. Yes. So the kneecap. And bear with me, I'm trying to get this guy in position. So the kneecap just on here. So it sits on the knee. Kneecap. Patella. Phalanges. Phalanges, anyone? Yes, fingers.
For feet.
Fingers or toes. Yeah, that's all right, Sinead. Yeah, so it's fingers or toes. So we classify the phalanges as the fingers right at the ends or the toes. So same name for fingers and toes. Pubis bone. So the pubis bone is situated as part of the pelvis, the pelvic girdle. So as we see it here, so the pubis bone at the bottom of the pelvis. Okay, so right at the bottom here, pubis bone. Radius. Sorry, not looking. Radius. Can anybody tell me where the radius is located?
Larger bone.
Yeah, forearm, large one.
Forearm again. So this time we're on top. So radius. You've got a radial pulse as part of just at the top. So we've got the radius, which is at the top, and ulna underneath. So if I show you on the actual skeleton, so if we go thumb up, so the radius is the top one, and ulna is the bottom one. Okay. Ribs. Pretty simple one. The ribs obviously are part of our rib cage, 12 pairs of ribs. The sternum. Maybe tell me where the sternum is located. Erin, do you want to have a go with that one?
Is it like by your chest?
Yes. So the breastbone in the chest, right in the middle of the ribs. Good work. So the sternum right into the middle. The fibula. Fibula.
Small shin bone.
So be careful about describing it as shin bone, okay? Because the other one is the shin bone. So this one actually sits behind, okay? So the fibula sits behind the shin bone, okay? So the fibula here, okay? So just be careful describing it that way. So the fibula. Humerus, anybody? Humerus? Good, George. Yeah. So upper arm. So we've got the humerus. Some ways to remember is it's near your funny bone. So humerus is the large bone at the top of the arm, close to the funny bone. Ilium. Ilium. This is the one that tends to trick people a bit.
Is it the large part of your pelvis?
Yeah, good. So the large part of the pelvis. So it's this nice big flat bone here, large part of the pelvis at the top. Ischium.
Ischium's the small part with the hole in the middle at the bottom of the pelvis.
Yes, good. So if I spin them round, the ischium is this bone just at the bottom here. Okay, so the ischium. This is where your hamstrings attach. Okay, so the hamstrings will start at the ischium and run down the back of the leg. Ischium. Lumbar vertebrae. Lumbar vertebrae.
Third section of your spine.
Yeah, third section. So the lumbar section just down here. Don't know if you can see that. So lumbar section, lower back, we would kind of describe it as. So the lumbar section, lumbar vertebrae. Tibia.
That's the shin bone.
That's your shin bone. Good. Yes. So situated at the front. So this larger bone in the lower leg, the tibia. You can actually feel it when you put your hand down there. Sacral vertebrae.
That's the fourth part of your spine, isn't it?
So that fourth section, good. So between the lumbar and the coccyx, then we've got our sacral section. Again, oh, sorry. So the sacral section is here. Okay, so we've got the lumbar section, the sacral section, and then the coccyx at the bottom. Okay, and then finally our tarsals. Do you want to have a go at tarsals? So tarsals as part of the ankle, the bottom here. So if we think about in the hand, we've got carpals, metacarpals, and phalanges. In the foot, we've got tarsals, metatarsals, and phalanges. So if we think T for toes, so we know that tarsals are down towards the toes. So tarsals are the cube-like bones, then our metatarsals, the longer bones of the foot, and then the phalanges are our toes. And that's it. Okay. So a bit of a difficult one to kind of do through Teams, but hopefully it gives you a bit of an idea with regards to the location of the bones. And I've also got this slide here. I don't know how well you can see that, but I'll be sending these out, which labels each of them for you, so you can do a recap. A good little kind of activity to do for yourselves at home, if you can get some sticky labels. So you can get sticky labels. I get mine from Asda. You can get a roll of like 250 sticky labels. I'll send you out the list of bones, and then if you get somebody at home that can just stand there, stick the sticky labels on. So write the bones on each sticky label and stick them on the person at home, so you can learn the location of each of the bones. Do it without looking at the answers. See what you get right, what you get wrong. Check your answers, and then you can kind of do it again. And the more you do that, then you will be able to kind of upskill on the location of the bones. Okay, any questions before we move on? I've lost Sinead away. Cool. Okay, so next section then we're going to look at the functions of the skeleton. So can anybody tell me what some of the functions of the skeleton would be?
To protect the rib cage, protect the vital organs.
So protection is one. Yes, good.
Movement.
Anything else? Protection of vital organs?
Movement.
Yes, movement. So muscle attachment and movement. Good. Our first one. Anything else? Okay, so muscle attachment and movement is the first one that I've got on here. So the long bones of the skeleton act as levers. Muscles attach to these bones and pull on them to create movement. So if we think about our arm, so we've got the bicep muscle is attached down to the radius and ulna, it will pull on the radius and ulna to create movement. Okay. Our next one is storage of minerals. So minerals such as calcium and phosphate ions are stored in the bones to be drawn upon when necessary. So a site of storage for minerals. Protection of vital organs, as you mentioned. So the skeleton protects vital organs and delicate structures within the body. So we think about the skull protecting the brain, the ribs, the sternum protecting the heart and lungs, and the vertebrae within the spine protecting the spinal cord. Framework. So the skeleton gives the body its characteristic shape and provides a framework for support. If we didn't have our skeleton, we'd just be a big ball of meat sitting on the floor. Okay, so the skeleton gives us our shape and provides a framework for support. And then the final one is production. So the marrow cavity of some bones such as the sternum is a site of production for red and white blood cells. So our main functions of the skeleton: muscle attachment and movement, storage of minerals, protection of vital organs, and a framework for support and production of red and white blood cells. Okay, so the skeleton is split into two separate divisions. Does anybody know what they are? They both begin with A.
Axial and appendicular.
Good, yes. So our axial skeleton, first of all, is made up of 80 bones, and it lies along the midline or down the center of the body, and includes the skull, vertebrae, sternum, and ribs. So if we look at here, we've got our axial skeleton. So skull, vertebrae down the back, our sternum and ribs is our axial skeleton. Can anybody tell me what the main function, so of the 5 functions, what's the main function of the axial skeleton? So we think about the skull, the vertebrae, sternum and ribs. What do we think their main job is?
Protection of vital organs.
Good, protection, yes. So the skull protecting the brain, the vertebrae protecting the spinal cord, and the sternum and ribs protecting the heart and lungs. So it's all about protection. It does the other jobs as well, but the main job of the axial skeleton is protection. And then our appendicular skeleton, made up of 126 bones, includes the bones of the shoulder girdle, arms and hands, and the pelvic girdle, legs and feet. Can anybody tell me what the main function of the appendicular skeleton might be? Erin, do you want to have a go at this one? Any idea? So if we think about it, shoulder girdle, arms and hands, pelvic girdle, legs and feet. Can't hear you. Okay, so the main function of the appendicular skeleton is movement. Okay, so we think about it, the shoulder girdle, arms and hands, pelvic girdle, legs and feet. So the main function of the appendicular skeleton would be movement. Again, it does all the other jobs, but the main function will be muscle attachment and movement. So this is just a diagram of the axial and appendicular skeleton. So it shows you the axial skeleton down here and the appendicular skeleton here. Just be aware that some questions come up on the paper asking you which bone would be part of the appendicular skeleton or which bone would be part of the axial skeleton. So making sure, if we look at clavicle here, oh, hold on, let me get my laser pointer up again. So we've got the clavicle just here is part of the appendicular skeleton. Some people can get mixed up with that one because it looks like it lies down the midline, but it's actually part of the shoulder girdle, arms and hands. So appendicular skeleton. Okay. Any questions before I move on?
Would it be fair to say that the appendicular consists of just long bones?
Okay. Think about the carpals.
Short bones, yeah.
Yeah, the tarsals.
I mean, there's none in the axial.
We've got the, well, so we're going to look at bone classifications in a second, and hopefully that will answer, but both sections will have all types of bones. So when we look at it, so if we think about our ilium is a flat bone. If we look at the axial skeleton, the vertebrae would be irregular bones. Okay, so it kind of does mix up the different types of bones within each section. Okay, but I get where you're coming from. If we were to look at the appendicular skeleton, there are a lot of long bones that make it up, if I can speak properly. But we think about the carpals, we think about the ilium, the scapula at the back, as well, making up different types of bones. Okay, that's a good observation to make. Okay, a vertebral column then. Oh, okay to move on from that. Cool. So the vertebral column then we're going to look at in a bit more detail. So as we can see in the diagram here, it's split into 5 sections. So we've got our cervical, thoracic, lumbar, sacrum, and coccyx are 5 sections of the vertebral column. Now, we've got 4 natural curves named after the vertebrae that form them. So our cervical section is a forward curve. So we've got our forward curve here in the cervical section, a backwards curve in the thoracic section, a forward curve in the lumbar section, and then our sacral and coccygeal, so we classify them as the sacral section, is a backwards curve. So these curves will center the head above the body and make walking and maintaining an upright posture more easy. So this is what we would classify as neutral spine alignment. Okay, so when we're working with our clients, we're looking to maintain the 4 natural curves of the spine. So we're looking to maintain neutral spine alignment. So to do that, we need to make sure that our head is in neutral position, eyes looking forwards, rather than being chin up or chin down, where we're going to change that curve. So to maintain that natural curve of the cervical section, we keep the head in that neutral position. The thoracic section, we think about shoulders back and down, chest proud, to maintain that backward curve of the thoracic section. Our lumbar section then, we're going to switch on our core stability muscles. So all those core muscles around that lumbar section, we switch them on to maintain and protect the lumbar forwards curve. And then our sacral curve is where we've got a pelvic tilt. So the pelvis will tilt forwards and backwards. Can't really do it with the skeleton here, but our curve will change. Let me do that. So we've got our tilt forwards and backwards with the pelvis. And what we can do then is maintain that neutral position. So rather than being a forward tilt or a backwards tilt of the pelvis, we maintain it in that central position. Does that make sense? Okay. Okay, so there are 33 individual bones in total within the vertebrae, within the spinal column. So first of all, the cervical section. Can anybody tell me how many bones are in the cervical section? 7. 7 cervical vertebrae. Good. So the first is called the atlas, which supports the skull and forms a pivot with the axis. So we've got C1 and C2 right up the top here. So C1 and C2 form a pivot joint that allows rotation of the skull. So C1 the atlas and C2 the axis. One sits on top of the other and allows for that pivot to occur and rotation of the skull. Thoracic section is next. Can anybody tell me how many vertebrae in the thoracic section?
12.
12, good. So we've got 12 thoracic vertebrae, and they form joints with the ribs to form the rib cage. So if we count the amount of ribs we've got 12 pairs, and they will line up to form a joint with the thoracic vertebrae. Lumbar section. 5. Cool. So 5 lumbar vertebrae, the largest and strongest vertebrae. Any ideas as to why they would be the largest and strongest? So this is where all of our movement stems from. Okay, so when we play any sport or do any type of movement, it stems from this lumbar section. So we think about core stability, which is the muscles that surround that section of the body within that core. We need our largest and strongest vertebrae there to be able to create that movement, but also to help with shock absorption. So when you jump and land, that shock will go up through the legs and tends to end up in that lumbar section of the vertebrae. So we need our largest and strongest vertebrae there. Our sacral section, we've got 5 again, so 5 sacral vertebrae and 4 coccygeal. So the difference between the bottom 2 sections and the top 3 sections is the bottom 2 sections are fused to form the sacral and coccyx, okay? So these bottom 2 sections here, there's no movement between these vertebrae. There is movement between the top 3 sections. Okay. So the vertebral column then. So as we can see here on the right-hand side, we're looking down through the spine, okay? So we've got, sorry. So all the vertebrae join to one another to form a flexible column that supports the trunk and head and encloses and protects the spinal cord. So we can see this hole here is where the spinal cord will run down through the spinal cord. So we've got good protection all the way around for that spinal cord. In between each vertebrae, there are intervertebral discs, fibrous cartilage, which act as shock absorbers between each of the vertebrae. So if we didn't have that cartilage, we would get bone-on-bone friction between the bones and a lot of wear and tear. So that cartilage prevents that friction and allows for friction-free movement, and also helps with shock absorption if we were to jump and land, and stops those vertebrae from crashing on top of each other. Okay. Good. Okay, so we're going to move on now and look at 3 different conditions of the spine. So the first one we're looking at is lordosis. So as we can see here, lordosis affects the lumbar section of the spine. So I don't know how well you can see that, but we can see there's an overarch in the lumbar section. Can anybody tell me what might cause lordotic posture? An overarch of the lumbar section. Okay, so different things like sitting for long periods of time, where our hip flexor muscles will tighten and our gluteus maximus muscles will weaken. What that will do is it will cause what's called an anterior pelvic tilt. So the pelvis tilts forwards. We will try to counterbalance that, but then we create an arch in the lower back. Okay, so sitting for long periods of time, driving for long periods of time. Another thing that can cause this is pregnancy. So during pregnancy, as the fetus grows, the mother will try to kind of counterbalance it and can cause a lordotic posture. Okay, so if we remember lordosis, L for lordosis, affects the lumbar section of the spine. Okay, the next one we're looking at is kyphosis. So kyphosis will affect the thoracic section of the spine. So if we can see here where the head position should be, and with a kyphotic posture, we can see where the head moves forwards. Does anybody know how we may cause, or what can cause, a kyphotic posture?
That'd be bad posture.
Bad posture in general. So if you sit at a desk and you create bad posture, so if I'm sitting at my desk at my laptop in bad posture all the time, over time it will create a kyphotic posture. So we need to think about our desk setup and how we sit at our desks to reduce that effect of the kyphotic posture. Older age, people tend to kind of they can develop a kyphotic posture. So again, there's different exercises that we can do to kind of pull back, strengthen the upper back muscles to reduce the effects of a kyphotic posture. And our final one is scoliosis. Now, poor skeleton here has got pretty bad scoliosis. So scoliosis is where we've got that lateral movement of the spines, or a lateral position of the spine. And it'll be an imbalance on either side. So muscular imbalances on either side of the spine. People can be born with scoliosis, and there is surgeries that can be done to reduce the effects of it and to kind of bring it back to a straight posture. But what can cause it on a day-to-day activities are carrying a heavy bag on one shoulder all the time. So if you remember, if you were in school and you carried your bag on one shoulder, it can cause that imbalance. Carrying a child on one hip. So if you've got kids and you carry the child on one hip, you kind of knock the pelvis out of alignment, and imbalances then within what's called quadratus lumborum muscles on either side here can create a scoliosis posture. Okay, so what I've also got, guys, for you, and I'm going to send this out after the session, is a YouTube video which will explain the lordosis, kyphosis, and scoliosis. It's got some good animations as well within that video. I'm not going to play it for you now just for time, but what I want you to do is between now and the session that we've got at 12 o'clock, if you can watch that video, I think it's about 7 minutes long, watch that video, and then we can kind of catch up on that in our next session at 12 o'clock. Is that okay? Cool. Good. Okay, so moving on then to our bone classifications. So Adrian, you mentioned a couple of bone classifications earlier when we were talking about the axial and appendicular skeleton. So we've got 5 classifications of bones. So in here, we've got a description of each of the bones and our examples here. So long bones. Long bones have a greater length than width and consist of a shaft with normally 2 extremities. They contain mostly compact bone in their diaphyses and more cancellous bone in their epiphyses, and principally act as levers. So as we can see here, our examples are humerus, femur, fibula, tibia, ulna, radius, metacarpals, metatarsals, and phalanges. And if we look at these bones and where they're located, they are mainly used for movement, muscle attachment and movement. Our short bones, so normally about as long as they are wide, they're usually highly cancellous, which gives them strength with reduced weight. So things like the carpals and the tarsals, so our carpals, little cube-shaped bones, really, really strong bones within the wrist and the ankle. Our flat bones, so our thin cancellous bones sandwiched between 2 compact layers, they provide protection and large areas for muscle attachment. So again, if we look at our ilium here, lots and lots of space for muscle attachment. Similar with the scapula at the top here, lots of space for muscle attachment on here. Irregular bones form very complex shapes and therefore cannot be classified within the previous groups. So as we can see, they are irregular in shape. So the vertebrae and the calcaneus, which is in the heel, your heel bone, an irregular shape. And then finally, our sesamoid bone, a seed-like bone. So sesamoid bones develop within particular tendons at a site of considerable friction or tension. It serves to improve leverage and protection of the joint from damage. So our patella is our sesamoid bone, which helps. So if we didn't have our patella, every time I'm getting tied up with my headphones. So if we didn't have our patella, our movement at the knee joint would be very restricted, and we get a lot of pinching of the tendons that cross over this joint here. Okay, so as we describe our classifications, the name of the classification will go along with how it looks. So if we think about a long bone, as we look at it, it is long. If we look at a short bone, it is short. If we look at a flat bone, it is flat. If we look at an irregular bone, it is irregular in shape. And then our sesamoid bone is basically just our patella, but it's that seed-like bone. Any questions? I feel I've gone quite quick through that. Sure. Erin, you okay with this?
Yeah.
Okay. So into bone growth then. So can anybody tell me what the process of bone growth is called?
Ossification.
Ossification. Good. Okay. So bones are living and need a good blood supply in order to bring nutrients and oxygen and to get rid of waste products. The bone also needs nerves to send information to the brain about pain or damage caused to a bone. The bones at birth are mainly cartilage. As the skeleton matures, calcium and magnesium are deposited within the cartilage by osteoblasts. So osteoblasts are your bone building cells. This process of bone growth is called ossification. And ossification is complete by the age of about 25 years. The cartilage gives the bones their resilience and calcium gives them their hardness. So when we look,
quick question.
yes, go for it.
The ossification complete by the age of 25, is that the same for men and women?
Yeah, in general, about the age of 25 for both males and females. Yeah. Okay. So the structure of a long bone. So our long bone is made up of compact bone, which forms the main shaft of the bone. So I've just taken off his humerus here. So we've got the compact bone, which forms the main shaft of the bone, which is the diaphyses. So this section here, hopefully you can see this. So we've got the main section of the bone, the diaphyses, okay, the shaft of the bone. We've got spongy bone, also known as cancellous bone, which is found at the ends of the bone, which is the epiphyses. So this section here at the bottom and this section here would be our spongy cancellous bone, the epiphyses. So the diaphyses in the middle and the epiphyses at either end. Inside the bone, we've got our red marrow, which produces red and white blood cells and is found within the cavity of the bone shaft. With the exception of the ends of the bone, a fibrous sheath covers the bone called the periosteum. So surrounding the shaft of the bone, we've got like a cling film type substance, which surrounds the shaft of the bone and the periosteum. So periosteum has a rich blood supply and provides nutrients for the bone cells during growth and repair. So we've got a nerve supply, we've got our blood supply to the bone. So if we think about it, when we break a bone, we need to be made aware of it. So pain receptors within the periosteum and the nervous system will tell us that we've damaged bone. But also our blood supply. So to get the red and white blood cells out of the bone shaft, we need a blood supply. So the periosteum will be able to take that blood supply out. So it's like a cling film substance, but really, really tough and really, really hard. And that is also where our muscle attachment occurs. So if we've got a muscle that crosses the joint and attaches to the bone, it will attach onto that periosteum. Is everybody with me on that? Okay. And a long bone, so this long bone here is the femur. So it just shows you kind of how the structure of a long bone. So I've used the humerus to give you that example there. Okay. So moving on then to our final section, we're looking at the important implications for exercise of ossification. So growing bone is vulnerable to damage. So exercise training with children therefore requires care. Research suggests that exercise with young children needs to be of moderate intensity to have a positive effect on bone development. Resistance training with children should consist of high reps and low resistance, and heavy, strenuous work with young children could lead to overuse injuries and fractures of the epiphyseal plates, which could affect growth and future bone development. Okay, so bone growth occurs in the epiphyseal plates, which will sit here and here. Within a growing child, if we were to do heavy, strenuous work, lots of high weights and low repetitions, we can damage those epiphyseal plates. So we need to think about the type of exercise that we do when it comes to working with younger people and children. So we obviously don't want to damage these growth plates at either end. We want to make sure that we keep them safe. So as they grow, if we're doing resistance training, using body weight exercises is more appropriate than using like weights, like free weights or resistance machines. But if we are using equipment, to make sure that we keep the rep numbers high and the resistance low. Okay. Okay, so different factors that can affect bone growth. So bones change their size and shape during a lifespan. Increasing age and inactivity can lead to bone demineralization and fragile bones osteoporosis. So regular weight-bearing exercise will increase bone density, making it stronger as a result of the pulling forces exerted by the muscle on the bone. So weight-bearing exercise is any exercise that you're doing where you're holding your whole body weight. So walking, running would be classified as weight-bearing exercise. Cycling or swimming or rowing would be classified as non-weight bearing because you're sat down or you're floating in water. So the more weight-bearing exercise we can do means that our muscular system will have to pull on the bones to maintain and stabilize the body. So even if we're doing a standing bicep curl, the rest of the muscles in the body are keeping our skeletal system stable. And because of those pulling forces on the bone, it will increase bone density. So the more weight-bearing exercise that we can do and encourage people to do will reduce the effects of osteoporosis later in life. Okay, so osteoporosis is where bones become thinner and more fragile. Exercise does not need to be vigorous. Everyday activities such as walking are beneficial. And any weight-bearing exercise program is effective as it encourages an increase in bone density. So bones become stronger due to the pulling forces of the muscles on the bone. Without this action, bone loses calcium faster than it can be replaced. Oh, sorry. So that means basically that if we don't do enough activity, we can get degenerative disease, which is osteoporosis. So we're trying to encourage people to become more active, but becoming more active by doing more weight-bearing exercise. So examples of walking to the shop instead of taking the car would increase our weight-bearing activity. Using the stairs instead of the lift is going to increase our weight-bearing activity as well. And that concludes the session today. So what we've looked at today is looked at the major, identified and named the major bones of the skeleton, specified the functions of the skeleton, identified the role of the spine and effects of exercise on spine alignment. We looked at the 4 types of bone and understand their development, and then finally looked at the effects of exercise, age, inactivity, and hormonal status on bone structure. Now, in this afternoon session, we're going to do a little quiz like we did at the start of this session when we recapped cardiorespiratory system. Actually, not today, not this afternoon sessions, tomorrow's first session. Because we're doing more skeleton and bones in this afternoon session, then we're going to do a whole quiz at the start of tomorrow morning session to see what knowledge you've retained. So just a heads up on that. Okay, any questions, any comments, any feedback on the session that we've just done? Anything? Give me something. All good? Erin, you okay with everything?
Yeah, thanks.
Okay, right. As always, it's a lot of information that I've hit you in the space of an hour, but I'll be sending out all of the slides, all of the resources, so the video that I mentioned, and anything else, so the list of bones, things like that, I'll be sending out, and also the recording I will send out after this session as well. Okay, unless there's any other questions, I'm going to stop the recording.